Hi all, this is Shashikla, Assistant Professor Department of EC in Care College of Engineering. So today's topic is on to find the form factor and peak factor for the voltage waveform. It comes under Introduction to AC Circuits in Unit 1 BEE. Subject code is 3251. Okay, so to find the form factor and peak factor for the voltage waveform, right? So they are given the voltage waveform like this. Okay, so we need to find the form factor. So to find the form factor, the formula is RMS value divided by average value. That is, it is a ratio between the RMS value and the average value. Okay, to find the peak factor, the formula is it is the ratio between maximum value and the RMS value. Okay, since the circuit is since the waveform is a symmetrical one, the average value of half a cycle can be determined. Okay, so we know that this waveform is a symmetrical one. Since it is following the same pattern, we are set to that as a symmetrical one, and for symmetrical waveform, the average value of half a cycle can be determined. Okay, so first we need to find the average value of that particular waveform. In order to find the average value, we know that the formula is area of the waveform under half the cycle divided by period. Okay, so in order to find the area of the waveform under half the cycle, that is here area of the, they are saying that as area of the waveform under half the cycle. This is considered as a half the cycle. So we know that there are three kinds of shapes in this half cycle. One is left triangle, and another one is right triangle, and the middle one is rectangle. So okay, the left triangle lies in the 0AB regions, OABO region, and the right triangle lies in the region of ECDE. Okay, so the middle one, that is rectangle, lies in ACDBA. Okay, so we'll be having three kinds of regions, three parts in the given waveform. Okay, so area of the waveform under half the cycle is equal to area of triangle OAB plus area of triangle CDE plus area of rectangle ACDB. We know that area of triangle is half BH, breadth into height. So area of angle OAB is half into breadth into height. Half into breadth is T by 8 here, since they are give that as T by 8 in the question itself. So we know that breadth is T by 8 and the height is 50 voltage. See, 50. So half into T by 8 into 50, that is 3.15 T. That is going to be our triangle OAB area. Okay, so the next triangle is CDE. Area of the triangle CDE is half BH. Since it's an equivalent triangle, the area of the angle CDE is half into B into H. Here breadth is T by 8 and height is 50. Okay, the same value will comes for triangle CDE. Since it's an equilateral triangle, the same value will come for both the triangles. No, so 3.125 T. Area of rectangle is ACDB. That is nothing but breadth into height. So breadth here is T by 4. Look at the waveform. They have given that as in the E part, they have given the time periods. Breadth is T by 2. In the B point, they have given the breadth as T by 8. But in the D, they have not given anything. I just calculated that. So just calculate here T by 2. And here they mentioned as T by 8. What is the value which lies between T by 2 and T by 8? Think about the series. T by 2, T by 4, T by 8. So it is coming under a particular series, no? So we can able to find the D value is T by 4. Okay, we need to apply that here. breadth is t by 4 into 50. The rectangle, so we find that rectangle breadth is t by 4 and height is 50, that we already know. Okay, so the area of rectangle is 12.5 t. So we found that area of triangle OAB is 3.125 t, area of triangle CDE is 3.125 t, area of rectangle ACDE is 12.5 t. So since they are asking for the area of the waveform under half the cycle, we need to add up all those portions. Okay, so 3.125 t plus 3.125 t plus 12.5 t, that is 18.75 t. That is going to be our average value to average value top side. Okay, that is area of the waveform under half the cycle. Area of waveform under half the cycle is 18.75 t, and the formula is divided by period, that is nothing but t by 2. We need to find the value for the half the cycle only, no? So for half the cycle, the limit lies between 0 to t by 2. Okay, so that we have to write here. Time period is t by 2. So by dividing the 18.75 t divided by t by 2, we will be getting 37.5 volt as the average value. Next we need to find the RMS value. To find the RMS value, the formula is, it's a root of area of the squared wave divided by period. So area of the squared wave for half the cycle we need to find. So as I said before, there are three portions in the waveform which is given in the question. So for area of the squared wave for angle OAB is nothing but 1 by 3 B head square. Since we are finding the value for squared wave, we need to write that as 1 by 3 B breadth into height square. That is 1 by 3 into t by 8 into 50 square. And the next triangle value is 1 by 3 into t by 8 into 50 square, plus area of the squared wave for rectangle ACDB is B into h. So that is t by 4 into h square, B into h square. Okay, so summing up all those squared waves, we will be getting the value as 833.35 t. That is our RMS value. Okay, so for RMS value, it is the root of squared wave divided by period. That is, we will be getting 40.82 volts. Okay, so we already got average value, RMS value. We can straightly find the form factor now. We know that form factor is the ratio of RMS value and average value. So we need to substitute the RMS value here in the numerator side, and we need to substitute the average value in the denominator side. We will be getting form factor as 1.088, and for peak factor, that it lies in the ratio of maximum value and the RMS value. So maximum value is nothing but 50. That is, in the question itself we can find this is the maximum value. So the height of the waveform, the maximum height of the waveform is 50, and that is said to be as maximum value. Okay, so 50 divided by RMS value which we found there. Okay, that is going to be our peak factor. So according to the question, we can able to find form factor and peak factor. It's an important university question. Kindly note it down, and thank you so much.